Integration 2, example 8. Before we start this example, just insert around the denominator a square root. That's just been missed out of the question here. This is quite a standard integral, and those people who do further maths, you might have seen something like this before when you were integrating hyperbolic functions, inverse hyperbolic functions. It might ring a bell as we go along. Anyway, so let's get started. Slightly different. X is in terms of u rather than u being in terms of x. So when we differentiate, start off with, we'll actually be doing dx by du to start off with. So that will be 4 cos u, and then cross multiplying dx is 4 cos u du. Now let's have a look at that denominator. I'll leave the square root out for the time being, and we'll just have a look at 16 minus x squared. Let's see if we can simplify that first. So x squared would be 16 sine squared u, remembering to square the number as well as the trig function. And that might say something to you. You might be able to think what to do next. If you can't, I'll give you a little hint. Maybe that will help. 1 minus sine squared, hopefully you're now saying, yeah, that's 16 cos squared u. So that means that the square root of 16 minus x squared will be the square root of this, which is 4 cos u. So that denominator is 4 cos u. So looking at the question, we've got a 1 on the numerator. We've decided that the denominator is 4 cos u. And then dx. Remember, dx always goes on the numerator. So dx is 4 cos u as well. Now, this is quite unusual. We've got 4 cos u on numerator and denominator. So we're actually just integrating 1 with respect to u. The integral of 1 is u. So, that seems rather strange. Let's have a look at what we had in the question. So, x is 4 sine u. So that means that x over 4 would equal sine u. And so u is actually the inverse sine of x over 4. So that means that our final answer is the inverse sine of x over 4 plus a constant.